With new space discoveries making headlines every day, did you know that the sun has just recently spewed dark plasma into space from its far side? But what do you know about this dark plasma? Or better, do you know that this event has caused a geomagnetic storm disrupting life on Earth? If you were curious to find out more about this new discovery by scientists, then watch this video till the end. Also, if you haven't subscribed, please subscribe and hit that notification button. With that said, let's dive right into it. Coming back to the point, just recently, coronagraphs at NASA's Solar Dynamics Observatory and the Solar and Heliospheric Observatory satellite, an Earth-orbiting spacecraft jointly controlled by NASA and the European Space Agency, both picked up an eruption of dark plasma that spewed out of our sun on March 11th. According to spaceweather.com, SOHO observed a coronal mass ejection, a torrent of plasma that exited from the sun's southwest limb. And if you didn't know it by now, coronal mass ejections are large explosions of plasma and magnetic field from the sun's atmosphere, also known as the corona. Moreover, compared to solar flares, which are bursts of electromagnetic radiation traveling at the speed of light, reaching Earth in just over 8 minutes, it is observed that CMEs travel at a more leisurely pace, relatively speaking. For instance, did you know that according to the Space Weather Prediction Center of the National Oceanic and Atmospheric Administration, or NOAA, at their highest speeds of almost 1,900 miles per second, or 3,000 kilometers per second, CMEs can reach Earth in about 15 to 18 hours, while slower CMEs traveling at around 155 miles per second, or 250 kilometers per second, can take several days to arrive. What's more is that these colossal clouds of plasma have two extremes. Either they wreak havoc by destroying and damaging power grids and satellites, or, on the other hand, they can also trigger stunning aurora displays. So now, with the introduction of CMEs out of the way, according to space weather, this dark plasma that the sun has spewed into space from its far side is not dark, as in the same sense of dark matter or dark energy. Instead, it is cooler, less luminous, and denser than the gas surrounding the background sun. But if you're wondering, how did scientists observe this difficult-to-see dark plasma in the first place? Well, you see, the energetic particles driven by the shockwaves in CMEs can be seen as snowy spots and streaks in the time-lapse data from the SOHO coronagraph. As they come into contact with SOHO sensors, they emit fleeting luminous speckles, which makes them observable to scientists. What's more is that the energetic particles released by these dark plasma eruptions were expected to have only minor geomagnetic impacts when they reached Earth, similar to past CMEs. For instance, according to spaceweather.com, NOAA experts have modeled the CME and found that it might brush Earth's magnetic field on March 15th, causing a G1 class geomagnetic storm. Our Earth's magnetic field, also known as the geomagnetic field, is generated in our planet's interior and extends out into space, creating a region known as the magnetosphere. Without the magnetic field, life on Earth as we know it would not be possible, as it shields us all from the constant bombardment by charged particles emitted from the sun and the solar wind. To give you a clearer picture of what happens to a planet when it loses its magnetic field, you only need to look at Mars. With that said, contrary to the claims and observation that this spewing of dark plasma would cause a G1 class geomagnetic storm on Wednesday, the solar explosion released black plasma into space and ended up causing a moderate G2 class geomagnetic storm on March 15th. And if you're wondering, but what are these G1 and G2 geomagnetic storms? Don't worry, we've got you covered. The G scale, used by the United States National Oceanic and Atmospheric Administration, which rates the storms from G1 to G5, i.e. G1, 2, 3, 4, 5 in that order, where G1 is the weakest storm classification, corresponding to a KP value of 5, and G5 is the strongest, corresponding to a GP value of 9. According to space weather, auroras and mild transient G2 class geomagnetic storms were in fact signs of this CME's repercussions on Earth today. In a phenomenon known as polar cap absorption (PCA) event, these particles were directed towards our planet's poles by the geomagnetic shields of Earth. Solar physicist Keith Strong, in a tweet on March 15th, noted that it seems that the storm is saturating radio signals in the polar regions at 5 MHz and below. This will interfere with transpolar flights, causing delays, cancellations, and diversions. Interestingly, did you know that while the majority of these storms have little impact on Earth, extremely powerful solar storms can seriously damage terrestrial technologies? One such storm, the Carrington Event of 1859, significantly disrupted global telegraph service and produced auroras much further from the poles than usual. The Carrington Event was a large solar storm that took place at the beginning of September of 1859, just a few months before the solar maximum of 1860. In August of 1859, astronomers around the world watched with fascination as the number of sunspots on the solar disk grew. Among them was Richard Carrington, an amateur skywatcher in the small town of Red Hill near London, England. On September 1st, as Carrington was sketching the sunspots, he was blinded by a sudden flash of light. Carrington described it as a white light flare, according to NASA spaceflight. The whole event lasted about 5 minutes. The flare he saw was a major coronal mass ejection, a burst of magnetized plasma from the sun's upper atmosphere, the corona. In 17.6 hours, the coronal mass ejection traversed over 90 million miles, or 150 million kilometers, between the sun and Earth and unleashed its force on our planet. According to NASA spaceflight, it usually takes CMEs multiple days to reach Earth. The day after Carrington observed the impressive flare, Earth experienced an unprecedented geomagnetic storm, with telegraph systems going haywire and auroral displays, normally confined to polar latitudes, visible in the tropics, according to NASA science. Carrington put 2 and 2 together and realized that the solar flare he'd seen was almost certainly the cause of this massive geomagnetic disturbance. This was a connection that had never previously been made, according to NASA spaceflight. The solar storm of 1859 is now known as the Carrington Event in his honor. Luckily for us, according to NOAA SciJunks, solar storms like the Carrington Event happen only once every 500 years or so, though solar storms with half the intensity of the Carrington Event are more frequent, occurring about every 50 years. However, with climate change and space observation bringing in new discoveries every day, it is now believed that no one can be certain when the next Carrington-level event will occur, as space weather is notoriously difficult to predict. With that said, what do you think about this new discovery? Do you think that we may be facing the next Carrington-level event pretty soon? Or do you believe that there is some time for such a colossal event to occur? Let us know in the comment section below. Also, if you enjoyed watching this video, do press the like button and tap subscribe to stay notified and keep watching amazing videos about space telescopes, NASA news, and other space updates. See you in our next video.